Welcome to the Swisstronik step-by-step guide on how to mint a private ERC 721 token using Hardhat. In this video, we'll cover the entire process. First, we will set up the project in Hardhat and create a new project directory. Then we will configure the Swisstronik network and set the private key. After this, create a private ERC 721 smart contract and also modify and compile the smart contract. Next, deploy and mint one NFT with the private ERC 721 contract to the Swisstronik network, and finally, we'll verify the transaction on the Swisstronik blockchain explorer. Let's take a quick look at the privacy features of the PERC 721 token. The private ERC 721 NFT contract is a specialized version of the standard NFT smart contract that prioritizes privacy by restricting access to token information. Unlike traditional NFT contracts where all data is public, this contract ensures that only authorized parties can view and interact with the tokens. Few key points. Privacy protection. Only token owners can check their own NFT balances. Prevents public scanning and tracking of NFT ownership. Ownership system token ownership details are private and only visible to the owner. Approved addresses can also verify specific token ownership. Transfer controls. Only verified owners or approved addresses can transfer tokens. Transfer events are not publicly broadcast for enhanced privacy. Minting mechanism creates new tokens with private ownership assignment, prevents duplicate tokens, and maintains balance accuracy. Approval management owners can permit specific addresses to transfer their tokens. All approvals are automatically cleared after token transfers, so let's get started. Part 1. Setting up the project. Before moving on to this, if you haven't yet installed Visual Studio Code for Code Editor, Node.js, and NPM, please watch our previous guide on how to deploy a simple smart contract on Swisstronik blockchain using Hardhat. First, let's set up our project. Open your terminal and create a new project directory. Write the command mkdir deploy PERC 721 token and navigate to this project directory. cd deploy PERC 721 token. Now install Hardhat. Use this command npm install --save-dev Hardhat. It will take a few seconds to install. After installing Hardhat, initialize a new Hardhat project. npx Hardhat init. When you run npx Hardhat init, it sets up a basic project structure with all the necessary configuration files. Follow the prompts to create a JavaScript project. Hit enter yes. Let's open the project in the code editor, use command code dot and hit enter. As you can see, there are a few folders and files here. Let's delete lock.sol in the contracts folder and also ignition file. Before we proceed, we need to set a variable with your private key. You will need this key to sign transactions on the blockchain. To get your private key, open your MetaMask wallet, click on the three dots in the top right corner, select Account Details, then click Show Private Key and copy it. To set the variable, use the following command: npx Hardhat vars set private key. After running the command, enter your private key, paste the key you copied earlier, and hit enter. Next, you need to configure the Swisstronik network in our Hardhat configuration file. Open the hardhat.config.js file in your project and add the following code. You can find this code in the sample repository in the script.gist file below. Just copy and paste into the configuration file. In this configuration, we import the necessary Hardhat tools and set the Swisstronik network URL. The Accounts field uses the private key you stored earlier to sign transactions. This setup allows us to deploy contracts to the Swisstronik testnet. Now you are ready for the next step. Let's create the private ERC 721 smart contract. Part 2, creating the private ERC 721 smart contract. Copy the code and paste it into a new file in your Hardhat Projects Contracts folder. Name the file perc721.sol. This file contains the solidity code for your private ERC 721 token. Let's understand this private ERC 721 smart contract. The first line specifies the license under which the code is distributed. In this case, it's the MIT license. This line sets the Solidity compiler version to 0.8.27 or higher. Different Solidity versions have different features and syntax, so specifying the version ensures compatibility. It starts by inheriting the IERC 721 interface, which includes functions like balance up to check how many tokens an address owns, owner of to identify the token owner, transfer from for transferring ownership, approve to allow someone else to manage a token, and get approved to check who is approved. The contract has a public name and symbol for the tokens, which are set when the contract is deployed. The ownership of each token is tracked through a mapping, where each token ID is linked to an owner's address, and the number of tokens an address owns is also tracked. There's an approval system allowing token owners to grant permission to others to manage specific tokens. The transfer from function allows the transfer of tokens, ensuring the caller is either the owner or has been approved, and it updates ownership and balances accordingly. The mint function lets new tokens be created by assigning ownership to a specific address, provided the token ID doesn't already exist. Although the contract includes event definitions, like transfer, they are commented out, so no events are emitted when actions occur. The contract focuses on ensuring only the owner or an approved person can interact with key functions, adding a layer of privacy not always found in standard ERC 2121 contracts. Now install the Hardhat tools and Swisstronik Web3 plugins in our project. To install this, run the command npm install anomic foundation Hardhat Web3v 4 Web3 utils ish a Swisstronik shirt Web3 plugin Swisstronik Web3 save dev. You can copy from the GitHub repository. Make sure you are in the root of the project directory. After the successful installation, we can proceed to the next step. Part 3. Deploying the private ERC 721 smart contract. Let's deploy the smart contract using Hardhat. In your project directory, create a new file in the scripts folder and name it deploy.js. Here's the deployment script. First, it imports the ethers library from Hardhat and the FS module from Node.js to interact with the blockchain and file system. In the main function, the script deploys the private ERC 721 contract, which is located in the perc 721.sol file, passing in the contract's name, private NFT, and symbol, PNFT, as constructor arguments. It then waits for the deployment process to complete by using wait for deployment. Once the contract is successfully deployed, its address is retrieved with getAddress and saved in a text file named contract.txt using the fs.write file sync method. Finally, the deployed contract's address is printed in the console. If any error occurs during this process, the main function catches it and logs the error, setting the process exit code to 1 to indicate failure. This script automates the deployment process and ensures the contract's address is easily accessible. To deploy your contract, run the following command in your terminal, npx hardhat run scripts/deploy.js. Network Swisstronik. If the deployment is successful, you'll see your contract's address in the terminal output, just like on my screen. Also, as you can see, we have a contract.txt file. This file contains the address of the contract we deployed. Part 4. Minting one private ERC-7221 token. With our contract deployed, it's time to mint our first one private ERC-721 token. Create a new script in the scripts folder and name it mint.js. Let's write the script for minting one token. You can find this repository in the description. Copy this mint.js script from here and paste it into your mint.js file. Let's understand this. It begins by importing the necessary modules, including the ABI, Application Binary Interface, of the private ERC-721 contract, the Swisstronik plugin from the AT Swisstronik/Web3-plugin-Swisstronik package, and the File System Fs module. In the main function, the Swisstronik plugin is registered with the Web3 instance using the network configuration URL. The script retrieves the deployed contract address from the contract.txt file, which was previously saved during the contract deployment process. After loading the contract address, it fetches the account details using web3.eth.getAccounts and assigns the first account to the from variable, which will be used as the minting address. A new instance of the private ERC-721 contract is created using the ABI and the retrieved contract address. The token ID to be minted is specified, in this case token ID 1. The script then calls the mint function on the contract, passing the account address and token ID, and submits the transaction. After the minting transaction is completed, it logs the transaction hash and details, confirming the successful minting of the token to the specified address. If an error occurs during the execution, it is caught and logged, and the process exits with a failure code. This script effectively automates the process of minting a token on the Swisstronik blockchain using a deployed ERC-721 contract. To mint your private ERC-721 token, run the following command in your terminal. npx hardhat run scripts mint.js-network Swisstronik. After running this command, you'll have successfully minted one private ERC-721 token on the Swisstronik network. Let's check on Swisstronik Explorer page. Just Google for the Swisstronik Testnet Explorer. Or you can directly access this link, https://explorer-evm.testnet.swisstronik.com. You can find this transaction link on a Swisstronik EVM Explorer by searching for your wallet address or the smart contract address, as you can see on my screen. As you can see, we cannot directly check how many NFTs were minted and transferred to specific addresses because this data is private and only the owner of the tokens can view it. We need to add the NFT contract to our wallet. First, copy the contract address from the terminal. Click on Import NFT in your wallet and paste the contract address here, and also add NFT ID. In our case, NFT ID is 1, as you can easily add NFT in your wallet. Part 5. Publishing the code to GitHub. Now that your project is complete, it's time to publish the code to a GitHub repository. Start with navigating to GitHub and creating a new repository. Once your repository is created, push your project files to GitHub. Use the following commands in your terminal to initialize Git, add your files, commit them, and push them to the remote repository. Let's copy commands and paste them into the terminal. This will push all your project files to GitHub, making them accessible online. Finally, we need to fill in the required details in the task card on the Swisstronik Testnet 2 dashboard. So copy the address of your deployed private ERC-2121 contract from your terminal or contract.txt file. Paste the copied contract address into the designated field for the deployed private ERC-721 contract address. Before you submit it, double-check all the information to ensure accuracy. Once you're confident that everything is correct, go ahead and click the Submit button to complete your task submission. Congratulations! You've successfully minted a private ERC 721 non-fungible token, deployed a smart contract using Hardhat, and submitted the necessary details to complete the task. Thank you for watching this tutorial. See you in the next video.